Okay, this is a Lego robot that I have made, and I've made it out of, well, pretty much my own Lego, and literally my own Lego from when I was a kid. My son plays with it now, and I thought I'd build a robot using a Raspberry Pi. And the way I've done it is I've centered it around this Raspberry Pi Model A, which is in under there, and I put this Raspberry Robot board on top of it. And the Raspberry Robot board gives you control lines for 2 motors. And the biggest advantage of the Raspberry Robot board is that it powers from the same single power source. Well, I think it's the biggest advantage. So that in there is 6 AA batteries, and the power line runs down here and powers both the Raspberry Pi and the Raspberry Pi Model A and the Raspberry Robot. Cool. So the way I've done it is I've used these old school motors, little old school 4.5 volt motors. The Raspberry Robot actually kicks out 5 volts, but yeah, whatever, half a volt over voltage won't be such a big deal. And then underneath, you can see I've geared it all up, made these 2 gearboxes through 3 large cogs. That works, gives the motor a lot of torque. Unfortunately, it does mean it's quite noisy, but hey, it works. And then at the front I've got this jockey wheel arrangement that just spins around as the 2 drive wheels activate. And to complete it, I use this Logitech controller, which is a wireless controller, and I use the 2 thumbsticks, one for the left wheel and one for the right wheel. And with the camera in my hand, it's going to be quite difficult to do, but let me try and demonstrate to you. You probably want to see it work. So here we go. I push forward, I pull back, I pull one forward and one backwards. Oh, and it should turn around. One forward, one back. There we go. And we back up. And then go forward. You can hear the gears working are quite noisy. Have a look here, you can see the gear assembly in action. So there you go. Now to make the software side of things work, I actually had this sitting on my desk for a while and I didn't do anything with it because I wanted to do it differently. I wanted to have like a controller program on a laptop and then send HTTP signals to it and blah 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 blah. That was all too complicated. What I ended up doing is just plugging the nano controller for this directly into the USB for the on the Raspberry Pi A. And when I was developing it, I actually had a hub in there and I had a wireless controller, and then I could log into the robot, write the Python code, and then once I'd done it all, I pulled all that out and just plugged the controller in there. So yeah, it has a bit of Python code that uses Pygame, and Pygame, I use Pygame to read the joystick inputs, and then the value of those paddles literally maps directly to the motor speed. You can use the RR robot or the RRD robot library to control the motors on the Raspberry Robot. And it's quite easy. I just test for each of the conditions, both forward, both back, and then alternate conditions, and then send the appropriate value to the motor output. That's pretty easy. And then of course I've got these flashing lights. I set that up so that when you power up the Raspbian system, you know that the actual Python code has started running. So when it's flashing, you know, okay, good, the code's running and it's looping and it's waiting for input from the joystick. As soon as I do some input from the joystick, they just go on, they stay on, hard on. I could do more with that, but you know, it's serving a purpose right now. That's it. Cool, homemade Lego robot with old school Lego parts, meeting new school electronics. See you later.